In this video, we're looking at page 3 of the homework packet, and we're going to do what I'll call a type B problem, and that's preparing a solution. So let's say I want to prepare 1 liter of 1 big M, which is 1 molarity NaCl solution. Okay, first I'm going to grab a container that's 1 liter. So I could use this beaker. I like this 1 liter volumetric flask because it has a little etch mark in the glass, which tells me how much I need to fill this to at 1 liter. So, and then I can shake it and turn it and twist it and mix it a lot easier. So that's going to help me get my 1 liter of solution. But what do I have to do? It doesn't even tell me. Assume I have some solid NaCl. And if we assume that, we're going to have to measure that. The only way we're going to measure that is either by counting particles, and pretty hard to count particles that you can't see. Okay, the other way would be to weigh it, and that's what we're going to have to do. But how much do I put in? And that's what we want to calculate. So we're going to do a calculation to figure out how much we put in and then show you how to make that solution. So there's a couple tasks that we have here. So first off, you have what you're trying to prepare 1 liter of 1 molarity solution. So I'm going to just kind of steer away from this for a second and go to our definition of molarity, and that's on a different page. We know we want to make 1 liter of 1 molarity solution. So on this page, this is a mole train guide, which you, by the way, have in, I think it may be page 10 of your homework packet, and somewhere toward the back. But our definition of molarity is molarity equals moles, technically moles of solute over liters of solution. Now I can manipulate this. This is kind of like manipulating density equals mass over volume. You can manipulate it other ways. Let's say I multiply each side by liters. The liters cancel out, and I get molarity times liters equals moles. So by multiplying each by liters, the liters cancel out, and I get molarity times liters equals moles. Another thing I could do is take molarity times liters equals moles and divide each side by molarity. So the molarity cancels out here. I get liters equals moles over molarity. So these are 3 ways to express how these variables, if you know 2 out of 3, you can solve for the unknown one. So remember our mole train, and I might just slide this up slightly. Going from grams to moles, you can't quite see it on here. Maybe I can shrink this down slightly. I don't want to make it too small. Okay, we can see, oh yeah, to go from grams to moles, going grams to moles, we divide by the molar mass. Going from moles to grams, we multiply by the molar mass. And we know moles to atoms, we multiply by 6 times 10 to the 23rd, atoms to moles, we divide. But what about going from moles to liters? We're adding a step to this. Okay, for gases, we've kind of talked about going through 22.4. Let's not worry about that. Let's look at this. How does this work? If you know liters and you know the molarity, what is it? Liters times, going on this side, we're looking at this side, liters times molarity equals moles. Oh, that's what we said, liters times molarity equals moles. So going from liters to moles through molarity, it's liters times molarity equals moles. What about the opposite? What about going from moles to liters? Oh, moles divided by molarity equals liters. Moles divided by molarity equals liters. So you can either use these equations to go convert liters to moles, or you can just use this mole train, which is really the same thing. Now, what happens is we were given 1 liter and 1 molarity. So what we're going to do is take 1 liter times 1 molarity times 1 mole per liter to get 2 moles. Well, what's 1 times 1 going to be? It's going to be 1. And then what we're going to do is take that and times it by the molar mass to figure out how many grams we get here. So I'm going to just go back and show that. And I'm going to take, let's see, I think we have it right here. I have 1 liter of 1 molar solution. So I'm going to take my 1 liter liters, and then I'm going to times that by my molarity, which I said was 1.0, and molarity is also moles per 1 liter. So that's what molarity is. So 1 mole per 1 liter. Okay, so that's getting me to moles. And then I said I was going to multiply that by the molar mass, which would be what? Moles on the bottom and grams on top. Now, what's the molar mass of NaCl? Oh, magically done over here. 23 and 35, it's 58. And it is 58 grams in a mole. And I think when we looked at the mole train, it said to multiply everything. So that is what we are going to do. So 1 liter times 1 mole per liter times 58 grams per 1 mole, and that's going to equal 58 grams. Now that's how much we need, but it really doesn't answer the question yet. So I'm going to just finish that up. I'm going to say put 58 grams. So I'm going to sneak this in here. Put 58 grams of NaCl into a container. So I'm going to grab like this volumetric flask and I'm going to put in 58 grams, which is 1 mole, dump that in here. And it says add enough water to equal 1 liter of solution. So notice I'm not going to add 1 liter of water because that's going to over exceed the amount. I'm going to add enough water to reach 1 liter, and then I'm going to mix it around. Okay, and then I have my solution. I have 1 liter of 1 molarity NaCl solution. So how does this work if I'm trying to make 0.2 liters of 0.1 molarity solution? Right away, I'm thinking I'm making less of it and I'm making a weaker concentration. So I'm probably going to use less salt. Okay, I'm going to follow the same format. It looks like I just have to multiply all these things together, but instead of 1 liter, I had here, I'm going to use 0.20 liters. So I'll say 0.20 liters. And then I'm going to times that by the molarity. Now the molarity, instead of being 1.0, is 0.10. Now notice the, I'm going to say 0.10 moles. Notice the number, the liters actually stays the same when you're doing molarity as 1, but the moles is what's going to be the thing that changes depending on how concentrated it is. So I'm going to say that is 0.1 moles per liter. So I got my liters, I times it by 0.1 moles per liter. And then is the molar mass the same? Yes. So that's going to be the same. And I can say that is what, 58 grams per 1 mole. So now I multiply that through, and I think I get like 1.16, or if I round it, I can even say 1.2 grams. Now notice this is a lot less. Does that make sense? Yes, I'm using a container instead of this size. I'm using a 0.2 liter container, which is, I don't know if you can see that, quite a bit smaller. The other thing is I'm using a 1/10 as many moles. So I'm making it a lot less concentrated. So what's 1.2 grams? It's probably a pinch of salt. Okay, so a pinch of salt is about 1 gram. So something like that in this container, and I'd mix it, dissolve it. So I'm just going to change this here and say put 1.2 grams of NaCl into a container, add enough water so the total is, this time it's going to be what? 0.20 liters, and then I'm going to mix that. Sorry, that got in the way a little bit there. So again, the same type of thing. You're multiplying liters times molarity times the molar mass in both cases, but this time you had less liters and you had less molarity, making it be a smaller amount I'm putting in to make that solution. Okay, so that is an example of a solution problem. Number 5, we'll show it on the key, but that's also an example if you just want to, even if you're not prepping a solution, I say, hey, I have this many liters, this molarity, how many grams do I need? You can solve a problem using this by multiplying these different pieces together. Thanks for watching.